Okay, you're gone. You're completely new part of your life.
Help my cousin make tomato sauce.
Oh, that's so cool. That looks really yummy.
Hello, everybody. My name is Haley Stoner, and today I'm going to be giving you a little bit of my perspective into STEM. Alrighty, everybody. So, a little bit about me. Currently, I'm a PhD student at Dartmouth College, where my research focuses in surgical robotics. Before we get into the nitty-gritty with that, I'm going to back it on up and tell you guys a little bit more about my past and what inspired me to get into STEM. My inspiration for the STEM field derived from three main factors. The first being my innate ability to tackle problems involving mathematics and science with enthusiasm and ease. As a kid, I always loved running around and exploring my environment. Through the use of the scientific method, I got into loads of trouble, like discovering how to open windows as a toddler and making a house escape, and teaching my cousins how to get out of child leashes while at theme parks, which we may or may not have stayed with our families, may or may not have left our families, who's to say. The second factor was the child. Which contrive creative solutions to an endless supply of new problems. The Rube Goldberg experiments are one side of this coin. So say I want to eat cereal. Well, maybe I'll just use a spoon and just eat the cereal. Or I can get a robot to feed me with it. You know? Different solutions, different problems. But the third most essential factor is the ability to aid others with STEM. I wanted to devote my life to helping others, and the best way that I could do that was through the application of my scientific prowess. When I was a young child, I would go around looking for things to pick up and dismantle and reassemble. Legos and pillow forts were busts, but didn't always satisfy the tinkering phase. One time, my parents let me disassemble our home telephone set, along with helping change the oil and tires on our cars. In elementary school, I joined the Lego Robotics team, and then swapped over to Mu Alpha Theta, get it guys, math club, in high school days. I also like to play video games and compete in sports, along with taking advanced coursework and working part-time at Chick-fil-A, where it was my pleasure to serve you. But why am I telling you all of this? Well, if you feel like you've had a similar past or can't satisfy the itch to tackle new scenarios or keep learning the world around you, STEM would be a great place for you. I obtained my bachelor's in mechanical engineering from the University of Florida while also minoring in electrical engineering and mathematics. Fun fact, the University of Florida was founded on the basis of an agricultural school. So, during my time in undergrad, I started a robot farm. The first robot project started with picking up doodads and gizmos off the ground in my design and manufacturing lab. It was mostly used around these parts to drop off tennis balls and bins for the doggies. Next up, we added the tailgater to the corral. This cold reptile could cook off burgers and serve drinks autonomously. Woo-wee! Was that one a tough one to herd? In our next pin, we got ourselves here a more sophisticated bot that could play air hockey autonomously. Look at that there puppy garden technique. I should replace some of the herding dogs with it. Anyway, the last one in the undergrad pastures is the mean green tricycle machine. This baby could be ridden for miles, where it could charge up a cell phone with its USB ports from harvesting solar rays. Well, now, let me hang up our boots here for a second. In addition to those doggone days, I also worked for a mixed reality headset company called Magic Leap, where I ran a lab for the quality inspection along with designing parts for the calibration of the headset itself, and for the automated test system testing team at the Kennedy Space Center for SLS, so the Space Launch System, so new manned rocket, where I programmed and helped write work procedures as well. I'm going to be providing you all with a very basic overview of what my job entails and what exactly is surgical robotics. So, the main concept of my line of work is mechatronics. Mechatronics is the combination of three main principles: electrical engineering, computer science, and mechanical engineering. Mechatronics can be applied to any project that involves all of these principles. For example, an automated thermostat, or something a little more flashy, a robotic dog, perchance? Boston Dynamics, anyone? But anyway, I am responsible for taking each of these disciplines and applying them to the medical field in the best way I know possible: robotics. So, Surgical robotics is surgery conducted through the use of robots. The most common surgical robot deployed in hospitals today is the Vinci. It's a 6-degree freedom move. It offers 6 degrees of freedom movement, basically can move just like a human, and is manned by a surgical console controlled by the surgeon. A certified technician is trained to swap out the specific instruments on the robotic arms while the surgeon guides the tools inside the patient. This helps create a more sterile field, a better overall recovery times for the patient, and most importantly, higher success rates out of surgery. My research involves bettering and improving this process. I'm a little limited right now in what I'm able to show you in my lab, so I think I'll save off on the big reveal until a later date when I get some papers out there. What are my other hobbies? Well, I am glad that you all asked. I don't know if you guys can guess it, but I have a lot of hobbies. I like to cook. Homemade pasta is the best pasta. Hike and backpack. Stream video games on Twitch. Run. Read. Lots of reading. I'm a part of a book club. Really great. Highly recommend. Fight competitively with lightsabers. Yes, I said it. Lightsabers. In an organization called TSL, the Saber Legion. Check it out. Pretty awesome. And international. And play board games that are like Dungeons & Dragons. I also like to play Dungeons & Dragons, but that's a little difficult right now. And I also highly recommend Gloomhaven for those of you who are board game fans out there. Really great. You gotta get a group together to play it though. But amazing. Anyway, I definitely want to try and get involved also in a musical hobby at some point in time, but who knows when that'll happen. But basically, the takeaway from this is to make sure you have work-life balance. In school, you have assignments that can be completed within a day or two. When it comes to work, the projects you're assigned usually can take up to a year, if not longer than that. This is a common theme in all terms of work. Just try to make sure to keep work and extracurricular activities separate. That way you don't get burnt out and, you enjoy life and work more. Before we all part ways, I wanted to provide a little bit of sound advice I've learned over the years. First off, if you don't understand something, ask questions. That being said, if you haven't tried the problem first, asking questions will only lead you down more of a wild goose chase. So my motto is, try the problem first, and if you still can't get to the end goal, ask questions. Now, another piece of advice, never be afraid to answer a question with, I don't know. That is something I learned in industry. If you don't know the answer to something or know a partial answer, say, I don't know, but I'll look into that for you and get back to you. This immediately snuffs out any confusion that could arise from misinformation in the workplace and shows that you're able to tackle a problem that you're not at all familiar with. Anyway, those are the main takeaways from my years in STEM. Thank you all for watching this video. I hope that it provided you a little bit of a sneak peek of what a future in STEM might look for you.
Hi everyone, my name is Joanna and I'm a second-year PhD student at Northwestern University. I work in a lab on campus developing new medical device technologies, soft electronics, and bioelectronics, which are essentially electronic devices that interface with humans or other living things. I'm going to take you to my lab now and then I can show you around. Let's go. One of the research projects that I work on is the development of a medical device that will detect when a person is overdosing from drugs by looking at the amount of oxygen in their blood and rescues that person by providing emergency medication called naloxone or Narcan. The device has a component called an oximeter that shines light and measures how much is reflected to know how much oxygen is in the blood. It's a pretty cool concept, and it's actually used all the time in hospitals and other settings today. You might have heard of a similar concept which is called pulse oximetry, and it's what I'm demonstrating in this clip. Every time the researchers in my laboratory come to work, we measure this as a precaution because of COVID-19. When someone's overdosing from taking too much of a harmful drug, the amount of oxygen in their blood drops dramatically, so this is how the device is triggered. Our lab was actually featured on the news for these devices, and I got to be on TV because I'm one of the team members working on them. Here's a clip.
The first responders administering naloxone, a life-saving drug, to someone who has overdosed. But what if the addict's alone at the time of an overdose? One Northwestern University professor has developed an implantable device that would administer the drug when it senses that a person is overdosing.
That's why Professor John Rogers and his team on the Northwestern campus are developing this implant that is smaller than a pacemaker.
Let me show you how they're made. This is what our fully assembled devices look like. They contain plastic pieces and very complex electronic circuitry, including those oximeters which are able to measure the amount of oxygen in the blood. Going back to the beginning, first we have to assemble and modify each of the pieces individually. So here I am drilling holes into plastic pieces that will later be assembled. This allows the devices to be filled with the medicine that it carries, naloxone, later on. I also use a laser cutting machine to precisely cut various items in the lab, and I use what's called a spin coater to make very thin sheets of flexible and stretchy polymers that go into our devices or other ones. Next, I'll show you how I make one of these polymers, which is called polydimethylsiloxane, or PDMS. These polymers are soft and stretchy, so we use them to encapsulate our devices, which means to add an exterior layer to them so that nothing sharp or hard is sticking out. First, I weigh the polymer, and then I use a special mixer to mix the two components that go into it, so they're mixed up very, very well. When it finishes, I can pour it into whatever shape I need it to be. In this case, I'm adding it to 2 different molds, which we custom make in our lab using what's called a CNC milling machine. CNC machine is like a big drill controlled by a computer. It can make all different shapes in a block of plastic or metal just by slowly drilling down into the material. Once we have the polymer in our mold, we have to get rid of any bubbles that might be trapped, otherwise they could ruin our encapsulation. I put the molds into a vacuum desiccator and open a valve that pulls a very high suction, making the pressure inside of that desiccator very low, which is kind of similar to outer space. By lowering the air pressure inside of the container, these bubbles rise out of the sticky polymer, and then I can use an air gun to blow short bursts of air onto the bubbles and pop them at the top surface. Once that's done, we put the polymer into an oven to bake it, which is called curing. It turns into a solid that's not sticky anymore. So now I can remove the pieces from the mold and I can show you that they're stretchy and flexible. When I make the drug delivery devices, I have to prepare them first, then put them into their mold and add the sticky polymer. Then I add a covering which stays on while they cure, and the finished products look like this. Once they're removed and filled, you can see the part where their medicine goes inside. It's blue. We also test the devices. This is a clip of the wireless oximeter working, and another clip of a different version where I'm testing with my finger. You can see the red light coming through my fingernail, which is part of the test working. We can control the devices with a computer interface and use it to run other experiments that ensure that the devices work correctly, including this one where the device is stored underwater and monitored for a long time to make sure it will keep working. We have to prove that the device releases the medicine, so I also get to produce other videos like this one. This is probably my favorite part of work. You can see the blue liquid leaving the device, and the blue liquid is like the medicine that the device ejects. Outside of lab, as a PhD student, I take many classes, like this one about defects or non-perfect parts of materials.
Beyond the help of resurrectors, they embrace having opposite birth perspectives.
One of the coolest parts of my experiences so far was actually learning to operate a fire extinguisher in case there's a fire in my lab. This is my friend Maddie demonstrating. I might do a lot of research, but I also have hobbies outside of the lab. These include photography, taking care of my many plants, reading, and taking care of my kitten. Her name's Ruth. Thank you so much for watching, and I hope you have a great day. Bye.
Well, hello everyone, and thank you all so much for coming to watch this Q&A session for our Life in the Day of a STEM-itist with Haley and Joanna. Haley, thanks for coming by. Joanna, it looks like she might be a minute late, but I'm sure she just got caught up in lab making more of those life-saving devices. Since we did get quite a lot of questions, and we got over 50, I'd like to get through as many as I can. And so we're actually gonna go ahead and get started. So Haley, why don't you go ahead? I know we watched your video, but just reintroduce yourself and kind of talk about the general path that brought you to what you're doing now.
Sure. Well, hey everybody, I'm Haley Stoner. I am currently a PhD student at Dartmouth, and I am a second-year biomedical student. So I started undergrad as a MechE, and then I went off into the workplace and decided, you know what, I want to go into biomed. So I went back to school, and here I am now. And I'm working currently on surgical robotics is my field.
Perfect. Joanna, sorry about that. We jumped the gun by just a minute, but if you want to go ahead and reintroduce yourself and kind of talk about the path that got you to what you're up to now.
Sure. Can you hear me?
Yeah, perfect. Go
Okay.
ahead.
I did my bachelor's in chemical engineering at the University of Michigan, and I decided I wanted to switch fields and do more things on the material science side. So I took a year in between going for my bachelor's degree, and then I applied to PhD programs in material science. And so that's what I do now. And I'm at Northwestern and I'm a second year. So it's been a couple years since I graduated college, but now I'm in school again.
Okay, lovely. And that actually kind of touches on another question that a lot of the students had for y'all, which is how do you know that this is the field you want to pick? And do you ever consider, or did you spend a lot of time considering alternative career paths at all? So Joanna, if you want to address that a bit too, since you touched on it.
I used to want to be a doctor when I was little, like a medical doctor. And then in high school, I decided I didn't really want to be a doctor. I wanted to be a scientist and I wanted to be a chemist. So I wanted to do chemistry all the time. And talking to my parents, especially my mom, she thought, oh, well, you should do something more applied than just chemistry. Not that chemistry is not applied. It can be very, there are jobs to be a chemist everywhere, but I decided to be an engineer and a chemical engineer. And then during my schooling, learning about different fields in my classes and other types of things like that, I found out that material science was another field that's like sort of similar to chemistry, but it blends chemistry with things like physics to really look at stuff on the smallest scale and understand why it behaves the way it does. And so that's how I got from point A to point B, but I never thought when I was little that I wanted to be a material scientist or specifically a scientist at all, but that's what I want to be now.
Mm-hmm. Haley, how about for you?
I definitely flip-flopped everywhere. I'll just be real honest with that. So I started off as a kid, wanted to be a vet. Then I sat in on an operation where you put a poor doggo under, and I'm like, I can't do this. So I took a step back and decided in undergrad to be a mechanical engineer. But I also wanted to do like pre-med track and then like minor in teaching and have this crazy plan. But ultimately decided on mechanical engineering. And then I went off to work. And I'm like, you know what? I think I want to go back and help people. My job isn't helping too much. It's just entertainment. So I decided to take a step back and go into biomedical PhD. So I'm here now.
Lovely. Yeah. Kind of going into exactly what you do for your job, Haley, we had a few questions about how you find the inspiration for the particular things you decide to build. Is it a combination of science and hobbies? And you do a lot of collaboration of ideas with people outside of your lab.
Okay, let me step by step through that. All right. So I find inspiration because I ultimately want to help people get better. There's a lot of things out there in the medical industry that assist people. And one of those is surgical robotics. And that's something I can help with since I am not educated in any of the anatomy of the body or surgery. I can't do it myself, but I can talk to surgeons and we can coordinate that. So a little bit of work day to day. I'll work with a team. So I'll talk with surgeons, I'll talk with med students, I'll talk with my PI, and I'll talk with other people in my lab as well that are working on other components. Mostly we deal with spine stuff. And specifically for my work, it's upper spine with the robot. I think I missed a couple puts in that, but yeah, please correct me if I'm wrong.
No, that's on me for asking so many in a row. I should have broke them down a little bit more. But yeah, you addressed a good chunk of them and talking about particularly what you designed to do. Joanna, I had a question for you, or I suppose the students had a question for you as well about with the devices that you make. How do you deal with the responsibility that comes with making such an influential device? And if something goes wrong with one of the devices you make, if it does, how do you deal with that?
So for the responsibility, it's definitely a team effort. So we all take responsibility for the devices and their success. and their failure. So when we notice things that go wrong, we try to figure out the root cause of why the device didn't work, why it didn't turn on, why suddenly it stopped working. All of those things do happen, and we experience failures all the time. Last week we had 4 devices all fail at the same time. So we have to figure out why that happens, and we have to understand how we can fix it so that the next time when we make more, they don't fail like that. So they do work, but every step of the way, there's problems that we run into, and we're constantly evolving. So that's sort of how we deal with the failure part of things. And the responsibility, because we work with a team and we have people who work at different universities who also collaborate with us and work on the same devices. They do a different side of things. We do the engineering and we put the devices together and make them and test them. They do more of the testing with animals. So all of it together, we have this collective responsibility, and there's always the sense that if the devices aren't working or if the project is progressing slowly, the point is that things need to work, and that things we need to have faith that they're good and that we're not just making things up. So we always take our time with making sure that everything is the way we say it is. So we do multiple tests, we do in-depth characterization, stuff like that, so that we can make sure that we're being responsible while we develop the devices.
Of course, great answer. Haley, a question for you. Because y'all are both touching upon the biomedical applications of a lot of your devices. Do you think that doctors will ever be replaced by robots?
I think it's definitely a possibility. It's not in the near time future, but definitely I think with the advancements of AI and machine learning and deep learning, it definitely could happen, especially with the problem with like HIPAA and trying to get all that patient data in order to train the robots in order to do that autonomously would be difficult. But I think the databases are getting dedicated to that. And I don't see why it can't happen.
Yeah, what a world that would be.
Yeah.
All right, this next question is actually for both of y'all. And it's it kind of encompasses a lot of a very similar theme question that we got, which is, what is the most challenging part of your career? So Joanna, if you want to kick us off on that.
Sure. I would say the most challenging part of what I do right now as a PhD student is balancing time, because I also take classes and then I also do research, and they're both equally important. So balancing my time between them, and also just sort of finding the time to do all the experiments that I need to do, and picking which ideas and which experiments are the most important to me and what I think will be the most impactful, and deciding to do those rather than doing things, all of the things that I want to do, because there's always more ideas than there is time. So that would be my answer.
Haley, is that similar for you, or would you highlight a different challenge?
Oh, definitely have that challenge too. Time management is very difficult, especially with all the projects. But I think also what's kind of hard for me to grasp is that when you're tackling a problem, you go down the avenue and it might not be the solution, like it might not work. And you have to then regroup and then go on a different path and keep on chugging. So it's trying to overcome that and make sure you put the different steps in place in order to keep on going with your research and your job, get the goal.
Yeah, lovely. The counterpart to that question, since y'all highlighted some good challenges, would be, what is your favorite part or most enjoyable part of your careers?
For me, I think it's being able to do new things every day, and to a certain extent do what I want to do. I'm not totally my own boss. Obviously, I have a boss. I work for a professor. And we work together on different ideas, but being able to try new things like all the time and discover new things and hold these devices in my hand that I've made that actually work and can help like rescue a small animal from opioid overdose is really awesome. So that's my favorite stuff.
I think my favorite part of the job is also being able to do the new things every day. Definitely different than corporate life. Great. And I think the other thing is I love robotics. So I love working on machines and doing all the different aspects. So the hardware, software, and then testing. Testing's where it's loads of fun. If it works.
Yeah, that's always the fun part, when the challenge and the enjoyment kind of comes together. So clearly y'all are very, very excited about the careers that you have, but you also have things that you love outside of lab as well. And Joanna, the cat in your video was so adorable. So someone wants to know if you have more fun taking care of your cat or going to work.
That's a tough one. I think I have to pick the cat. She's pretty great. I mean, she's sometimes terrorizes me and gets into things she's not supposed to and digs in my plants, but I think I have to pick her. I think I have to pick Ruth rather than work.
Haley, in a similar vein about things you like to do outside of class, you mentioned that you were really into gaming. So a few people wanted to know what your favorite game was and if you were ever worried that games might impact your eyesight.
Oh, well, yeah, 100% they have affected my eyesight, but that's okay. We have glasses and these are blue light. Gaming, favorite game, that's tough. I've been gaming since I've been small. But I have to go back to Dark Souls, which is a very difficult game, but a fun game. And it sounds very dark. It is dark, but it's good. It's mature, okay? It's a mature game, guys.
All right. Another question, actually, this time for the both of y'all, is about, because we've talked a little bit about the career paths and how y'all decided that this is what you wanted to do. But kind of going back into what school was like early on for you, did y'all always have an inclination for math and science? And how do you deal with things that you don't know in the classroom with those challenges? So Joanna, if you want to kick us off on that.
I always did have a tendency and like favorite subjects of math and science growing up. What was the second part of the question? I'm sorry.
I'm sorry, yeah, I should have broken them up into two, but the second part is just with classes that you particularly struggled in, how do you deal with the challenges of those courses of not knowing something in the classroom?
Okay. So I think that changes at different points in your life. So now being a PhD student, when I don't know things in my classes, I can sort of think about whether or not they impact my job, my research, and sort of give different levels of importance to certain topics. Because if it's something that I'm going to need to use in my research, I need to work harder to understand it. But maybe if it's not something that I will ever probably pick back up again, that's not something that I need to focus and spend a lot of energy on if I just can't understand it, which definitely does happen. But previously, before I was a PhD student, before I knew what I was going to do, I think that I would mainly use tools like repetition and switching up the way I was learning. So reading versus speaking the things out loud or watching videos. Videos can be really, really helpful to learn certain concepts. I think I am more of a visual learner, so that's useful for me especially. But yeah, that's what I would say.
Haley, does that hold true for you as well?
I'm sorry. I was listening and I was paying attention, focusing. Could you repeat the question just a little bit?
Yeah.
I was focused.
No need to apologize for focusing. Yeah, Joanna has really great responses. So the question kind of came into two parts. The first is, have you always had an inclination for math and science?
Mm-hmm.
And the second is for courses that you've struggled in, or maybe you didn't have as much of an inclination for, how do you deal with those challenges?
All right, cool. And I think Joanna had great answers. So for the inclination of math and science, I always had an inclination for math and science. I love mathematics. That's why I minored in it. And I was on a math team. But anyway, besides the point. So if you don't know an answer to a question in class or how you tackled challenging things, I actually would rely on friends, and I'd make study groups and we'd do our homework together and learn together. And if we didn't know the answer to the problem, one of us would go talk to the professor. Actually, my first 3 days on campus in undergrad, I had formed a calculus group with people I had no idea and met them in the dining hall, and I proceeded to tutor them, and then we learned from each other and went through exams. So never be afraid to ask questions and rely on other people to help you get through. It's great for group work as well, but yeah, online videos are also a great solution for that.
Yeah, absolutely. And great friends are always made through struggles, particularly academically.
Misery loves company. That's the saying, right?
That is the saying. A bit of a change of pace now. Joanna, we got a question about the device that you mentioned in your video and how you can use oxygen to detect, if I recall correctly, if someone was had taken particular drugs or not. And someone just had a question about how that worked exactly, if you wouldn't mind talking about it a bit.
Sure. So you can measure, I'll talk first about how you measure the oxygen saturation. So that what you do is you use different wavelengths of light, so different types of light, and you shine them into the skin. And then inside of your skin, there's all these little teeny tiny blood vessels that are running back up to your heart and out to your extremities, and they're called capillaries. And so they have blood in them. And so when the light enters your fingertip, this is like, even if you've ever been to the doctor's office and they put a clamp like this on your hand and then it says like 99%, that means your oxygen is 99%, or your blood is 99% saturated with the oxygen that it should be, which is good. But anyway, so the light is shining through and it hits the blood, and then the amount of light that comes back is dependent on how much oxygen is in your blood. And so that's how you calculate it. So when someone takes opioids, which are very, very strong drugs, if they take too much, they overdose. And so when you overdose, you basically go into this state where the oxygen, like you stop breathing, and so oxygen is no longer entering your body. So the oxygen in your blood is decreasing because there's no new oxygen coming in. So the amount that's in your blood slowly decreases as it leaves your body. So what we do is we use those same like finger techniques where they shine the different light through your finger, and it's inside of your body instead. And then inside of your body, you have the same thing with blood and everything like that. And the detector sees how much light comes back and at what ratio. And then that tells you about how much oxygen is in the blood at that time. So that's how you can sense it. And yeah, when someone's overdosing, they go into respiratory distress, it's called. So they're not breathing. Their chest might actually seize up and nothing is moving. So then that's also how we know that there's a problem.
It's very interesting. I'm definitely learning a lot today myself. Haley, a question about the devices that you mentioned in your video. You did bring up the Vinci Robot that very many people were excited about. And one of the questions we got was how exactly technicians and doctors interface with the device. What is it like, and what do the technicians do versus what does the robot do?
Great questions. It's a lot of fun. I was actually in my rotations, I was able to sit in and watch the Da Vinci in action. So how they worked is the patient comes in, they are out and under anesthesia, and the robot is actually on this own mobile cart. And the mobile we'll get some vitamins here. So this is the robot. This is the patient. So the robot actually is wheeled over to the patient, and it has this little X or laser pointers that line up on the patient, and it conforms to one solid point. And that's where actually all of the robot arms will then make their incision points along that. And you'll have about 3 of the arms in the patient at once. And there is one arm that the technician actually sits next to. So it's kind of scary. So it's like a little spider here, and the technician will sit right next to one of the arms, very close up with the robot. There's a lot of safety precautions that are taken so that the technician is okay. But how it works then, it's the technician and bot over the patient, and the surgeon is over on the side here with a console. And you can think of it like those old sci-fi ones with VR headsets. So they actually just take their hands and put it into a console, and they have feedback and haptic sensors in their fingers for when the robot arms go in and guide them. And on the main screen, it'll encompass all their field of view, and it'll actually 3D render out the insides of the patient on the camera on one of the arms. So it's like a complex version of the game Operation, where you actually can see inside underneath the board where the pieces are.
Wow, that's very delicate and amazing. That's really cool.
Incredible.
Joanna, a question about the device that you mentioned that injects this that delivers this life-saving drug. Is that something that the device itself injects, or do you have to monitor the patient and kind of inject it as a doctor would?
That's a great question. So actually the device, part of the reason it's like cool and new, I guess in science we would call that novelty, is because the idea is that it's a closed loop system. So it's designed to both sense and look for if there's respiratory distress. So if the oxygen is decreasing, the sensor that's included on the device can tell. And so then if it sees that, then the idea is that the device itself turns on and delivers the drug automatically, so inside of the body. So there shouldn't be any need for a doctor or anyone else to intervene. And that's sort of why it would be really impactful, especially for people who suffer from drug addiction, because those are the people most likely to overdose. So those people are in recovery, they're trying to get back on track, they're battling their addiction, and they have much more of a chance that they would overdose than others. So that's why if it's right there, if it's implanted, if the drug is already inside the body and then it just gets injected when it needs to, if they suffer an overdose episode, then it would save their life without the need for first responders, so paramedics and EMTs to show up and rescue them, or someone else to be nearby and notice and give them the drug. Because if they don't get the drug in a certain amount of time, they will die, unfortunately.
Yeah, that's incredible. And kind of loops back into why y'all's team was featured on the news. That was really exciting to see. Haley, just a quick question for you again on the Da Vinci, because that machine, the robot is very clearly complex. Do you have any idea how long it takes to build something like that and the cost that goes into it?
Yes. So a robot of that size, it takes usually a team of engineers to work on, and then surgeons to coordinate that. I'd say at least a year for just design and development, and then plus another year for testing. And then you have to get it FDA approved, and that can take upwards of 2 to 3 years for a device in this manner. I know the Da Vinci is priced at like $2 million, which is very high. Yeah, I know the wide eye. Yeah, that's appropriate expression for that. But so that's taking into just the robot itself too. That's not with maintenance. That's not with the different coverings that have to be removed for patient sanitization in between, along with tools being reused, and staples. Apparently the staple gun also you have to replace them every so often, which is interesting. But so it costs a significant deal amount of time and effort, because it's something that has to be so precise, and it deals with patient care, and you don't you want to help the patient. You don't want to hurt the patient. So it's going to take a decent amount of time. With me on just my project, it's definitely going to be my whole PhD thesis, if not more.
Yeah, funny they'd have to replace the entire staple gun and not just the staples, but
yeah, it's interesting.
All right, well, we're coming up to kind of the end of our half hour, so I want to end on maybe a more exciting future note on what y'all want to do later on in your careers, or I suppose after your PhDs. So Joanna, if you want to kick us off and let us know if you have anything in mind.
Yeah, so I want to go work in industry. So that means like for a company that's just the opposite of academia, which is being a professor or working in universities. I might want to work for a startup. Which is like a small company that's just getting off the ground, and it's very small, very similar to like the research environment that you have as a PhD student. But in general, I want to continue doing research, and probably in the biomedical field with device research, sort of like what I do now.
Haley, how about you? Industry or academia or anything else that's possible?
Oh, yeah, of course. So fun fact, my program, I'm in the innovation program at Dartmouth, and how that works is I actually get business credentials as well, and they help fund my startup at the end of graduation. So my ultimate goal is to have a startup medical company at the end of it. So industry, but I'm my own boss, and I'll help employ other people and hopefully make changes to the world and help make it a better place. That's basically it.
That's really lovely. Those are some really great goals, y'all. Well, with that, I do want to say thank you everyone so much for joining us, and for our panelists, Haley and Joanna, for coming in and taking some time out of their busy world-changing schedules to talk to us about what they do every day. So y'all, please feel free to subscribe to this channel and keep an eye out for the next Q&A session that we have. Thank y'all. Have a good day.
Thank you for having me.